Okay, this video is a review of parent functions and transformations. So a lot of what you covered in Algebra 1 and 2 recapped here just to jog your memories. Okay, so remember, you're going to always start with a sketch or a mental picture of the graph of the parent function that we've reviewed. Okay, y equals x, you should know that that is a linear function, looks just like that. Y equals x squared is quadratic. You should know that it looks like that. That's where you start. A cubic, x cubed, goes through the origin, but it snakes up left to right. A square root. If you don't recall, the square root function starts at 0, 0, and it goes up to the right, but it's only in quadrant 1. Absolute value intersects at 0, 0, and it makes a v. Hopefully you remember that, v for value. And then lastly, the rational parent function. You may or may not have had this before, but you need to know it, especially for where we're headed. With the rational function, it's like a double L. Okay, it makes an L here, and it makes an L over here in quadrant 3. And the reason it makes the L's is because it has asymptotes. It has a horizontal asymptote, where y is 0, and has a vertical asymptote, where x is 0. Right, those asymptotes are going to be really helpful when we do transformations, and I'll show you how to use them here in a little bit. Okay, so first example, f of x equals x squared plus 2. So you know that that's a parabola. It usually sits at 0, 0, but the plus 2 here is a vertical shift. So instead of crossing at 0, 0, it's going to come up 2, but still maintain its shape of a parabola. All right, pretty simple one. This one, so I would describe the transformation as up 2. This is the square root parent function, and the minus 5. So it's the minus 5 is not happening within the square root, it's outside, so that means it's moving it down 5. Okay, so here's my graph. It usually is at 0, 0, but I'm going to move it down 5. So that means my curve is going to do this. Okay, moving it down 5. Horizontal shifts. Now you need to remember, horizontal shifts are shifts that only happen to the x-coordinate in the equation. All right? Sometimes you have lots of things happening, but this one is only happening to the x-coordinate. So again, and it's opposite of what you think. So if it's plus, it's not moving right, it's moving left. So this is moving me left 3 units. So normally I start at 0, 0 and I curve up, but now I'm going to go over left 3 and curve up. That's what the graph would look like. All right, absolute value graph, okay, usually is at 0, 0, but again, the subtracting of 5 is going to move me right 5. It's opposite what you think it should be. So my V is going to have a vertex right there, okay? So we're going to keep it pretty simple, but you need to remember the rules for where we're going. All right, so we put it all together. You have multiple transformations in each one. I want you to identify the parent function, describe the transformations, and sketch it, obviously without a calculator. Okay, so if this one, identify the parent function, that's an absolute value. So I know it's going to be a V. All right, and what transformations? Well, the minus 5 on the outside means it's going to go down 5. And the minus 2 inside the bars, meaning only happening to the x, means I'm going to go right 2 units. Okay, so I start with that vertex that's usually at 0, 0, and I go down 5. So down here, and I'm going to go right 2. And that's where my V will land. All right? Let's try another one. Identify the parent, describe transformations, sketch the graph. All right, so this is quadratic. So parent function is quadratic. The minus 8 means I'm going down 8. The plus 2 means I'm going to move left 2 units. All right, usually it centers right at 0, 0, so I'm going to go down 8. I'm going to go plus 2, so it's coming over here. So I know my graph's not quite long enough, but it'll work. All right, there's my transformed quadratic. Okay, on this one, identify the parent. Well, the parent function is my rational function. And transformations, well, all that's happening is something with the x here. It's plus 6, so that means I'm going to move it left 6 units, and that's it. And then I sketch it. Okay, so remember the parent function of my rational. It has an asymptote here at 0 and 0. And then it makes opposite L's. Now your asymptotes are your best friends when you're doing transformations because they're going to make all the changes for you. If I have to move left 6, then I take this vertical asymptote. It's no longer here at 0, but it's moving left 6 units. The horizontal one is staying the same in this case because there are no vertical shifts going on. If this had a plus something or minus something, that I would move my horizontal asymptote to follow whatever it says. And then I would show my curves. All right, so that's all you do with a rational transformation. This should be 9, sorry, example 9. Parent function, this is the square root. It is going to, the 4 is going to move me up 4. The minus 1 is going to move the graph left 1. So I'm going to go up 4, left 1, and it's going to do a curve like that. Lastly, example 10. You try this one on your own. Okay, we'll talk about it when you get to class, see if you got it right.